Sorry. Okay. Sir, కొద్దిసేపు ఆపండి సార్. Hi, good evening everyone. Here in this video, we will discuss Chopis method, some more problems. First, I will give the brief introduction to Chopis method. Chopis method is a method which is designed to solve the nonlinear partial differential equations. So the given equation is in the form of f of xy z pq is equal to 0. It is the given PDE. Be the given PDE. To solve the here P and Q are, it is maybe non-linear given PDE. It is maybe non-linear in P and Q. Non-linear in P and Q. In this case, we can take the Chopis equations. Chopis equations are I'm writing the equations dx by fp is equal to dy by fq is equal to dz by p fp plus q fq and dp by minus of fx plus p into fz, that is equal to dq by minus of fy plus q into fz. These are the Chopis equations. So in order to find the solution of partial differential equation, we have to find the Chopis, find the values of p and q from these equations. So we can solve for p and q, and the general solution can be obtained. The general solution is obtained by integrating dz is equal to pdx plus qdy. Okay, we need to find the values of p and q and substitute in dz is equal to pdx plus qdy. After integration, we will get the required solution of the given partial differential equation. This is the method of Chopis. Okay. Now, may I audible to all? Is it clear to all?
Yes, sir. Clear, sir. Voice clear, sir.
Okay. If f of xyz comma pq missing x, y, z terms. That means it contains p and q only. In this case, then we can take p is equal to a and substitute in equation 1. In the given equation, we'll get to q in terms of phi of a. So here the general solution and the general solution is dz is equal to a into p dx plus q dy only. So here we are taking p equal to a. So a dx plus q value phi of a into dy. Here in this case, when x, y, z are missing or the equations involving p and q. In this case, the general we have to take p equal to a and substitute in the given equation. We'll get q value in terms of function of a. So we can substitute in dz equal to p dx plus q dy. So p value a and q value is phi of a. We get the general solution by integrating these values. If f of xyz pq is equal to 0, missing x comma y terms. That means here the independent variables are missing. If the independent variables are missing, then we have to take p equal to, then take p is equal to aq. General case, and solve this equation and this equation for solve for P and Q and substitute and the general solution can be obtained by integrating dz is equal to pdx plus qdy. Okay, you have to remember, when independent variables are missing, we have to take p is equal to aq. When x, y, z independent and dependent variables are missing, we have to take p is equal to a. Okay, I am taking general case. If the dependent variable, if the dependent variable z is missing, when it is missing, in this case, then the given equation can be written in the form of f of x comma p is equal to g of g of y comma p. So here in this case, xp and yq terms are separated. So in this case is called variables separation of variables. So we can take the common value as a, say, and solve for p and q, and the general solution can be obtained by integrating dz is equal to pdx plus qdy. This is the same process. Okay. Now, an equation of the form z is equal to px plus qy plus f of p comma q is called Clairaut's equation. The form is very important. Z equal to px plus qy, where p equal to dou z by dou x, q is equal to dou z by dou y. So it is called Clairaut's equation. To find the solution of Clairaut's equation, just replace p by a and q by b. P by A and Q by B, where A and B are arbitrary constants. Where A and B arbitrary. So the general solution can be obtained by taking P equal to A and Q equal to B. Therefore, the general solution is Z equal to AX plus BY plus f of a comma b. This is the general solution. Okay, we will discuss these points in the last class. We'll do some more problems, also. Now we will discuss some more problems in this topic. Okay, first I'm taking an important problem. It is from set and also from AP JL and set problem. The complete solution of of 2xz minus px square minus 2qxy plus pq is equal to 0 is. Now we have options also. I'm writing the options here for our convenience. But z plus ay is equal to b into x minus a. Option A. So confuse capital A this. Capital B, z plus ay is equal to b into x square plus a square, and option C, z minus ay is equal to b into x square minus a square. x square minus a square, and d option z minus bx. Z minus bx is equal to a into a square plus y square. These are the 4 options. First, we can observe this equation contains all the terms x, y, p, q, and z. Okay, we can use the Choppe's auxiliary equations. Okay, Choppe's method. So first I am writing the Choppe's auxiliary equations, or simply Choppe's equations. Okay. Choppe's equations are dx by fp. Fp means differentiation with respect to p. So here x square, p derivative 1, here p derivative 1 into q, here minus x square. So minus x square plus q, first term, dy by fq. Fq means minus 2xy, and plus p, that is equal to dz by pfp, p into minus x square plus q into minus 2xy plus p, that is equal to dp by minus of fx plus p fz. Fx value here minus 2px. Sorry, first 2z minus 2px and there is no 2px minus 2qy. This is the dp by fx plus p into fz. This is fx only, plus p into fz. Fz means here only 2x. This is 2x. Okay. Now this is equal to dq by minus of fy. Only one term is there, minus 2qx plus q into fz, that is 2x only, 2x. ఓకే, ఇది జాగ్రత్తగా క్యాలిక్యులేషన్ చేయాలండి. ఇందులో మనకు సింపుల్ గా వచ్చేటట్టే చూస్తాడు వాడు ఈక్వేషన్స్. ఫస్ట్ డిఎక్స్ బై ఇవి ఇలానే రాస్తున్నా, నేను జస్ట్ బ్రాకెట్ వేస్తున్నాను. డివై బై నాట్ యూస్ ఆఫ్ దిస్ అండ్ డిజెడ్ బై దిస్ ఈజ్ ఈక్వల్ టు డిపి బై దిస్ ఈజ్ ఈక్వల్ టు సేమ్ టర్మ్స్ అండి, నో నీడ్ టు క్యాలిక్యులేట్. ఇన్ ద లాస్ట్ టర్మ్ 2qx, here 2qx, both are plus and minus will be cancelled, so it will be 0. 1 minute.
Try to solve the problem.
Now consider some dx by something, ఏదైనా వాల్యూ ఉండనివ్వండి, dp by 0. From this we can write dp is equal to 0. dp is equal to 0 means p is equal to a. A is the arbitrary constant.
DQ, sir. DQ,
Yeah.
sir.
Okay, dq, it is q. Okay, so it is q. So write q is equal to a in the given equation. I am taking this equation as 1. Now writing q is equal to a, we get the equation as 2xz. Therefore, from equation 1, 2xz minus px square as this minus 2qxy. 2qxy means 2a xy minus pq. pq means a p. ap is equal to 0. Okay. From this we can write 2xz, or we can take 2x common here. So remaining z minus ay. And we can take p common, or take outside p as common, that is x square minus a. So p is equal to, we can write from this 2x into z minus ay by x square minus a. This is the p value. We have p value and q value. Therefore, we can write the general solution. The general solution is dz is equal to p dx plus q dy. P equal to this value 2x into z minus ay by x square minus a into dx plus q dy, that is a into dy. So I am writing this equation as dz minus a dy is equal to 2x by x square minus a into z minus ay into dx, and dividing with z minus ay, we get to dz minus a dy by z minus ay is equal to 2x by x square minus a into dx. Now we can write the left side as d of z minus ay. d of z minus ay. So divided by z minus ay, that is equal to 2x by x square minus a into dx. So by integrating on both sides, we get a log. This is in the form of integral dx by x. So log z minus ay is equal to, it is in the form of integration of f dash x by f of x. So it is log f of x square minus a plus some arbitrary constant, we can take log b. So we can write z minus ay is equal to b into x square minus a. Okay, this is the general solution. Now we can check the options here. Z minus ay is equal to, only one option undandi, x square minus a square. ఇక్కడ a square ఉంది, మనకేమో a నే వచ్చింది. a అంటే ఆర్బిటరీ కాన్స్టెంట్ కాబట్టి a square ఉన్నా a ఉన్నా సేమ్. Now I am taking another problem from set the complete integral of the PDE, the complete integral of the PDE of the partial differential equation,
Sir.
Yes, sir. Power పోయింది సార్ మళ్ళీ.
Power పోయిందా? No problem, no issue, sir.
Okay, sir. Okay, sir. నేను టార్చ్ పెట్టుకున్నాను. The complete integral of the PDE 2 into root p plus 3 into root q is equal to 6x plus 2y with the usual notations. With the usual notations. Notations is. So here we have P x y P q x y terms. So here Z is missing. First I am writing the given equation 2 into root P plus 3 into root Q is equal to 6x plus 2y. Here clearly we can observe Z is missing. When Z is missing, it is variable separable form. So 2 into root P minus 6x is equal to 2y minus 3 into root Q. So this is the here variables are separated. So here in this case we can take a common value as A. Okay. So same. So now solve these two equations for P and Q. First I am taking 2 root P minus 6x is equal to A. From this we can write 2 root P is equal to A plus 6x and root P is equal to A plus 6x by 2. So by squaring on both sides, P value is A plus 6x whole square by 4. Okay, first equation. And the second equation 2y minus 3 root Q is equal to A. From this we can write 2y minus A by 3 is equal to root Q. So Q value is 2y minus A whole square by 9. Okay, this is the Q value and this is the P value. Okay, so substitute in the given equation, that is the general solution is just write in dz is equal to p dx plus q dy. So p equal to 1 by 4 of a plus 6x whole square into dx plus 1 by 9 of 2y minus a whole square. Okay. Now we can integrate on both sides into dy. We can integrate on both sides. We'll get the general solution. First, I'm taking here rough work. Put some t is equal to a plus 6x and differentiate with respect to x. We get the dt by dx is equal to 6 and dt is equal to 6 into dx, or dt by 6 is equal to dx. Okay, just dx value I'm writing. This is done in the first case. Dz is equal to 1 by 4 of, this is nothing but t square. Dx value is dt by 6 plus 1 by 9 of, in this case again take t is equal to 2y minus a. So dt by dy is equal to 2. So dt by 2 is equal to dy. And in this place we can write t square into dy means dt by 2. So I am writing dz is equal to 1 by 24 t square as this, dt as this, plus 1 by 18 t square into dt. ఇక్కడ t వేరు, ఇక్కడ t వేరు అండి, రెండు సేమ్ కాదు. Okay, so dz now integrate on both sides. By integrating we get z is equal to 1 by 24 of t cube by 3 plus 1 by 18 of, again integrate t square, we get to t cube by 3 plus some arbitrary constant b. Okay, so z is equal to, therefore z is equal to 24 is a 72, 1 by 72 of t. In the first case t value is a plus 6x whole cube and 18 3 is 1 by 54 of, in the second case t value is 2y minus a whole cube. plus arbitrary constant is B. This is the problem. It is set problem. Okay. Now I am taking another problem. The complete solution, it is JL Gurukul, recent Gurukul question. The complete solution of the equation Z equal to, I am writing here, P into X plus 2 plus Q into Y plus 3 is. Okay, direct question. So first I am writing this equation as Z equal to Px plus Qy plus 2P plus 3Q. You can observe it is in the form of Z equal to Px plus Qy plus F of P comma Q. So it is a Clairaut's form. It is in Clairaut's form. Whenever it is in Clairaut's form, the general solution Z equal to, just replace P by A and Q by B. Ax plus by plus 2a plus 3b. Okay. ఇంకా మనకు ఇటు సింప్లిఫై చేశాడు ఎలా అంటే a of x plus 2 plus p of y plus 3 ఇలా ఉన్నాయి ఆప్షన్. రైట్ ఆప్షన్ ఇస్ this. Okay. Now I am taking another problem from JL and also from DL. It is a JL and DL question. The general solution of root to P plus root to Q is equal to 1 is. So first I am writing the equation root to P plus root to Q is equal to 1. Here we can see the x, y, z are missing. When x, y, z are missing, here in this case, we have to take P is equal to A. When P is equal to A, then root to Q is equal to 1 minus root A. I'm substituting here in this. So Q is equal to 1 minus root to A whole square. So this is the Q value and P is equal to A is the P value. Therefore, the general solution dz is equal to A into dx plus 1 minus root A whole square into dy. By integration, z equal to ax plus 1 minus root A whole square into y plus arbitrary constant b. We can take c also. Okay. Option number c only. C. Now I am taking another problem from JL and PL. The general solution of P square minus Q square is equal to 4 is. Clearly, I am writing first equation P square minus Q square equal to 4. Clearly, we can see that x, y, z are missing. When x, y, z are missing, we have to take P is equal to A. Then substitute here in this, we get A square minus 4 is equal to Q square. So Q is equal to under root of A square minus 4. This is Q value. A is the P value. Therefore, the general solution is dz is equal to A into dx plus under root of A square minus 4 into dy. Now, by integration, we get z equal to ax plus under root of A square minus 4 into y plus arbitrary constant sum c. Okay. Now, I am taking another problem from Polytechnic lecturers, PL, very known problem. the complete integral, the complete integral of z square is equal to pq xy is z square equal to pq xy. So I am giving options also. Z equal to x power a y power 1 by a into b, and second option z equal to x power 1 by a y power a into b, and third option z equal to x power a plus y power 1 by a into b, and the fourth option z equal to x power a minus y power 1 by a into b. These are the options. Clearly we can observe here this equation contains all the terms x, y, z and pq. So first I am taking f of x, y, z, pq is equal to pq xy minus z square is equal to is equal to 0. We can write from this. So the Choppe's equations are dx by fp. Dx by fp means differentiation with respect to p. Then we get q xy, and dy by fq. Fq means p xy, that is equal to dz by p into fp qxy plus q into fq pxy, that is equal to I am writing here dp by minus of fx fx means here p q y, so it is p q y minus plus p into fz. Fz means minus 2z, and dq by minus of fy. Fy means pqx plus q into fz. Fz is minus 2z. So these are the Choppe's auxiliary equations. So to solve for p and q, we have to consider here. I am considering dp by p minus dq by q. dp by p minus dq by q divided by. That means we have to divide dp with p. So here in this case we have qy minus 2z, first term, dq by q. So minus of minus plus, here px minus 2z is equal to dy by y minus dx by x. You have to remember this, or you can remember the answer for this problem also. Very important. So when we are dividing dy with y, we get to px, and dx by x we get qy. So here minus 2z plus 2z will be cancelled, remaining px minus, here this is px, this is minus qy. This px minus qy and this px minus qy will be cancelled. So remaining we have dp by p minus dq by q is equal to dy by y minus dx by x. So by integration, log p minus log q is equal to log y minus log x plus some arbitrary constant. I am taking log A. Okay. So this is log P minus log Q means log P by Q. Logarithm will be also. Here Y by, or we can write this as A into Y by X. Okay. So we can write Px is equal to here. Therefore, Px is equal to AQY. Px is equal to AQY. And substitute in the equation number 1. That is, this is the equation 1. Okay, you can take this as equation. So Z square equal to PQXY. In place of Px, write AQY. Therefore, from 1, Z square is equal to Px value. That is AQY into remaining Px value Qy. So we have Qy. So Z square is equal to, we have Q square Y square. So we can take a arbitrary constant as A square also. Okay. It is become, because it is arbitrary. So we can write it is also A square, Q square, Y square. So here in this case, Z equal to AQY. From this, write the Q value. Therefore, Q is equal to Z by AY. Q is equal to Z by AY. And substitute here in this. You get Px is equal to A square into Q. Q means Z by AY. Into Y is there. So Y will be cancel. 1A also cancel. So P is equal to AZ by X. P is equal to AZ by X. We have the values of P and Q. So the general solution can be obtained by integrating dz is equal to P dx, AZ by X into dx plus Q dy, Z by AY into dy. Now by integration, we get Z is equal to, or we can write this as, by separating the variables here, dz by Z is equal to A by X into dx plus 1 by AY into dy. Just I am dividing entire equation with the Z. By integration, we will get to log Z is equal to A into log X plus 1 by A into log Y plus another arbitrary constant is log B. So this is nothing but Z is equal to X power A into Y power 1 by A into B. This is the solution. Okay. So you can check the options here. We have X power A into Y power 1 by A into B. So what is the right option? X power A into Y power 1 by A into B. So first option is the right option. Okay. Now I'm taking another problem from DL. The complete integral of of t square plus q square into y is equal to qz is t square plus q square into y is equal to qz is. So here x missing and x missing అయినప్పుడు మనకు స్పెషల్ కేస్ అంటే ఏం లేదు. ఓకే, ఒక ఇండిపెండెంట్ వేరియబుల్ ఉంది కాబట్టి సేమ్ చాపీస్ ఆక్సిలరీ ఈక్వేషన్స్ ప్రొసీజర్ ప్రకారమే చేయాలి. ఫస్ట్ ఐ యామ్ టేకింగ్ f of xyz pq is equal to p square plus q square into y minus qz, that is equal to 0 equation, or this is equation. So the Chopis equations are dx by fp. Fp means 2p y term coefficient only. Dy by FQ means 2QY is equal to dz by P into FP 2PY plus Q into FQ 2QY. This is 2. This is Q. Is equal to dP by minus of fx plus p into fz, no term of x, so 0, p into fz minus q, that is equal to dq by minus of fy means your p square plus q square, y differentiation 1 into p square plus q square minus plus q into fz is minus q. So we can write this as same dx by same term, dy by same term, and dz by same term is equal to dp by minus pq, here minus, so pq, dq by, you can see minus q square plus q square will be cancelled, dq by minus p square. So you can consider, now I am considering dp by pq is equal to dq by minus p square. So p will be cancelled by cross multiplication and take into inside, you get p into dp plus q into dq is equal to 0. By integration, we get p square by 2 plus q square by 2 is equal to some arbitrary constant for our candidate, I am taking a square. This is q. So p square plus q square is equal to a square with the p square plus q square value. Okay. Now substitute in equation number 1. Therefore, or we are taking this as equation number 2. Therefore, from equation 1, what is the equation? P square plus q square into y is equal to qz. We are substituting p square p square plus q square value is a square into y. Sorry, 1 second. P square plus q square, that value is a square only, a square y is equal to qz. So we can write a square y by z is equal to q. A square by z equal to q. So q value is this. So substituting this q value in the equation number 2. So from equation 2, p square as this, I am writing p square is equal to a square minus q square actually from equation 2. So that is equal to a square minus q square means a power 4 y square by z square. So this is equal to your LCM z square and 1 by z square of a square z square minus a power 4 y square. So we can take a square also common, a square by z square of z square minus a square y square. This is the value of p square. This is the value of p square. So we can write p value, that is a by z under root of z square minus a square y square. So this is p value. Okay. యాక్చువల్గా ఈ ప్రాబ్లమ్స్ ఎక్కువ సార్లు అడగలేదండి, ఒకసారి మాత్రమే అడిగాడు. జెడ్ స్క్వేర్ ఈక్వల్ టు పీక్యూఎక్స్వై. ఇంకొక ప్రాబ్లం కూడా ఉంది, చెప్పిన తర్వాత నేను ఒకటి చెప్తాను. We have p and q values. So substitute in dz is equal to pdx plus qdy equal to a by z under root of z square minus a square y square into dx plus q value a square y by a square y by what is the a square y by z into dy. So by cross multiplication we get z dz is equal to a into under root of z square minus a square y square into dx plus a square y dy. So I am writing this equation as z dz minus a square y dy is equal to a into under root of z square minus a square y square into dx. So z dz minus a square y dy divided by under root of z square minus a square y square is equal to a into dx. So this can be written as we can multiply and dividing with or we can multiply 2 on both sides simply 2 on both sides. So it is 2z dz minus 2a square y dy by under root of z square minus a square y square is equal to 2a dx. So it is nothing but d of z square minus a square y square divided by differentiating we'll get to 2z dz minus a square constant y square derivative 2 by dy. Denominator will be z square minus a square y square is equal to 2a into dx. Now integrate on both sides. By integrating, we get this in the dx by root x is 2 root x. So 2 root z square minus a square y square is equal to 2ax plus arbitrary constant b. You may take it to b also, okay, to cancel the 2 value. So under root of z square minus a square y square is equal to ax plus b. So we can write this as z square minus a square y square is equal to ax plus b whole square by squaring on both sides. Therefore, z square is equal to a square y square plus ax plus b whole square. This is the real question. Okay, and I am taking another question. The complete integral. It is a real question. The complete integral of the PDE partial differential equation p square plus q square into x is equal to p into z is. Here y is missing, only one independent variable is missing. So no problem. You can take f of x, y, z pq is equal to p square plus q square into x minus pz. Okay, that is equal to 0 or equation number 1. Now write the dx by Choppe's equations. Choppe's equations are dx by fp. Fp means 2px and dy by fq. Fq means 2qx. Dz by p into 2px plus q into 2qx. Sorry. Yeah.
Sir,
2q
dx by 2px minus z. Z Riley. Dx
minus z is also there. Okay, okay. It is minus z also. Minus there. And dp by
లైవ్ ప్రాబ్లం లో కూడా రాయలేదు సార్.
dp by minus of fx. Fx means your p square plus q square plus p into fz. Fz is minus p only. That is equal to dq by minus of fy. Fy term is 0, 2 into fz. Fz value is minus p only. So we can write first equation as this: dx by and dy by and dz by same. And we are simplifying this equation. Here p square and p square will be cancelled. dp by minus q square is equal to dq by pq. dq by p. So we can easily consider these two values. That is, I am considering dp by minus q square is equal to dq by pq. Here q will be cancelled. Now by cross multiplication, get p dp and take inside q dq is equal to 0. By integration, get to p square by 2 plus q square by 2 is equal to a square. Therefore, p square plus q square is equal to a square. Equation number 2. So substitute in equation number 1. P square plus q square into x equal to pc. Therefore, from equation 1, p square plus q square value is a square into x is equal to pz. From this we can write p value as a square x by z. And substitute in equation number 2. Now substitute in equation 2. So from this we can write q square value a square minus p square. So a square minus p square value a power 4 x square by z square. So here z square LCM, and we can take a square common in the numerator. So a square by z square of z square minus a square x square. So this is the q square value. So we can write q value as a by z into under root of z square minus a square x square. Okay. So we have the values of p and q, and substitute in dz is equal to p dx plus q dy. It is a square x by z into dx plus q. A by z into under root of z square minus a square x square into dy. P q values we are substituting. And same simplification like previous problem. Z dz is equal to a square x dx plus a into under root of z square minus a square x square into dy. So z dz minus a into under root of z square minus a square x square. I'm sorry, I'm taking the dx term inside. After this, that is a square x into dx, that is equal to a into under root of z square minus a square x square into d. So we can write this as z dz minus a square x dx by under root of z square minus a square x square, that is equal to a into d. So we can write the numerator as we can multiply with 2 and dividing with 2, we get to 2z dz minus 2a square x dx divided by under root of z square minus a square x square is equal to a into d. So we can write 1 by 2. This is d of z square minus a square x square by under root of z square minus a square x square is equal to a d. So 1 by 2 integration of this root z square minus a square x square is equal to a by plus arbitrary constant b. So z square minus a square x square is equal to ay plus b. From this,
దోమలు పోతాయి ఇంట్లోకు డోర్ పెట్టరా పోరి
z square is equal to a square x square plus ay plus b whole square. This is the general solution. Okay. ఈ 3 ప్రాబ్లమ్ చూడండి ఒకసారి టిఎల్ లో ఒకటే ప్రాబ్లం రిపీట్ అయిందండి ఇందులో. ఇది పిఎల్ అండి, సారీ ఇది రిపీట్ కాలేదు, డిఎల్ ఒకటి, ఇదేమో పిఎల్. రేర్ గా అడిగారు ఈ క్వశ్చన్స్. మీరు జేఎన్ శర్మ టెక్స్ట్ బుక్ చూస్తే అందులో ఇవి వరుసగా ఉన్నటువంటి ఎగ్జాంపుల్ ప్రాబ్లమ్స్ అండి. జేఎన్ శర్మ నేను ఆల్రెడీ నిన్న ఫోటో పంపించాను కవర్ పేజీ. జేఎన్ శర్మలో సీరియల్ గా ఉన్నటువంటి ఎగ్జాంపుల్ ప్రాబ్లమ్స్ ఇవి. ఓకే. Now I am taking another problem. It is also example of Jl&T Sharma. It is DL. The complete integral of the PD. The complete integral of the PD, partial differential equation. P equal to z plus qy whole square. Z plus qy whole square is. So first clearly we can observe it is here I am writing first equation. P is equal to z plus qy whole square. Clearly we can observe x is missing, so don't take that. So p square, p equal to z plus qy whole square as this equation number 1. I am taking f of x by z, pq is equal to z plus qy whole square minus p. You may take p minus z plus qy whole square also, that gives the same answer. So Choppe's equations are dx by ft, that is -1, dy by fq, that is 2 times of z plus qy into y, is equal to dz by p into -1 plus q into this term 2 into z plus qy into y, that is equal to dp by minus of fx. There is no term of x, so 0, plus p into fz. Fz means 2 into z plus qy, and differentiate with respect to z again. So z plus qy differentiation is with respect to z is 1. So p into 2 into z plus qy is equal to dq by minus of fy. Fy means 2 into z plus qy into q. Z plus qy into q plus q into fz. Fz means same term. So 2 into z plus qy into 1. Okay, you can teachers from Jata. Now I'm writing the equations. Dx by 1 minus 1 is equal to dy by 2y into z plus qy is equal to dz by minus p plus 2qy. This is 2qy into z plus qy. That is equal to dp by 2p into z plus qy. Okay. Now this is equal to dq by ఇక్కడ fy కదా అంటే 2q z plus qy z plus qy అంటే సేమ్ టర్మ్స్ ఉన్నాయి కదా. 1 second checking. fy minus of fy means 2 into z plus qy only z plus qy, not into q. Okay, plus q into, I'm writing clearly, fy derivative means 2 into z plus qy, again differentiate z plus qy with respect to y means it gives q also. Okay, q కూడా ఉంటుంది, plus q into fz means 2 into z plus qy into, again differentiate z plus qy, will get 1. So both are same terms and 2q z plus qy, 2q z plus qy. So we get 4q z plus qy. Okay na, 2q z plus qy. So we can consider now I'm consider dy by 2y into z plus qy is equal to dq by 4q into z plus qy. Okay, so here in this case మిస్ అయిందండి. I think dq term లో not out. Okay, no problem. Here z plus qy and 2 2's.
మైనస్ ఉంటుంది సార్ dq డివైడెడ్ బై మైనస్ సింబల్.
Okay, minus symbol missing, right? Yeah, minus.
dp బై కూడా ఉంటుంది సార్ dp లో కూడా.
ఇక్కడ కూడా ఉంటుంది. ఓకే, దాంతో పని లేదండి. Okay, we can write. Now we can write this as 2 into dy by y is equal to minus dq by q. So by integration we get 2 log y is equal to minus log q plus arbitrary constant sum a. So we can write y square is equal to a by q. From this
అక్కడ dq by minus 2q z plus qy కదా సార్.
equal to q is equal to a by y square. We have q value and substitute in equation number 1. Therefore, from equation 1, what is the equation here? P equal to z plus qy whole square. So P is equal to z as this z plus qy. Q means a by y square into y whole square as this. So here 1y will be cancelled. P is equal to z plus a by y whole square. Now P value, this is the P value. Now substitute in dz is equal to pdx plus qdy. So dz is equal to p value this same z plus a by y whole square into dx plus a by y square into dy. So I am writing this equation as dz minus a by y square into dy is equal to z plus a by y whole square into dx. So we can write this equation as this left hand side as d of z plus a by y. By differentiation, we get the dz plus a 1 by y differentiation minus 1 by y square into dy. So that is equal to z plus a by y whole square into dx. So we can write this as d of z plus a by y divided by z plus a by y whole square is equal to dx. Now integrate on both sides. By integration, it is in the form of integral dx by x. Integral dx by x is equal to minus 1 by x. So minus 1 by z plus a by y only is equal to x plus arbitrary constant b. Okay, you can write therefore x plus, we are taking outside inside or outside 1 by z plus a by y plus b is equal to 0. Okay, this is the general solution. We can write simplified solution. Therefore, we can write x plus y by a plus yz plus arbitrary constant b equal to, this is the general solution of the given debate. ఇక్కడ ప్లస్ బి కాకుండా is equal to b కూడా ఉండొచ్చు. ఇలా ఉన్నా కానీ we can write the, these 4 problems are serial example problems in J&T Sharma. Up to z square equal to pq xy నుండి ఈ వరుసగా p square plus q square into y, p square plus q square into x, and last problem, that is p equal to z plus qy whole square. J&T Sharma textbook లో చూస్తే మీకు వరుసగా serial problems. Okay, these are the problems related with the Tropy's method. Okay, now I am taking another topic called the important topic, linear partial differential equations. Linear partial differential equations. Differential equations with the constant coefficients. With the constant coefficients. Already we are seen this topic in ordinary differential equations. In ordinary differential equations, to find the linear differential equation with constant coefficients, we have to find the complementary function as well as particular integral. Here in this also, in partial differential equation also, we can find the complementary functions here and the particular integral pi. Here the complementary function is denoted by zc and the particular integral denoted by zp. Okay, there are some rules for to find the complementary function, and there are some rules to find the particular integral of the given differential equation, partial differential equation with the constant coefficients. First, we see the form of the linear partial differential equation with constant coefficients. An equation of the form, f of d comma d dash of z is equal to f of x comma y. They ordinary differential equation lo ela undedi equation f of d into y is equal to q of x. Only x independent variable kabatti f of d into y is equal to q of x. ఇది dependent variable. ఇది dependent, ఇదేమో independent. ఇది ఇక్కడ dependent variable, x independent variable, y కూడా independent variable. కాబట్టి ఇదే ఫామ్ ను టూ ఇండిపెండెంట్ వేరియబుల్స్ కి ఎలా రాస్తామంటే f of d comma d dash of z is equal to f of x comma y, where x and y are independent variables. An equation of the form f of d comma d dash of z equal to f of x comma y, where f of d comma d dash is differentiable operator, is differentiable operator. Then the general solution is z is equal to cf plus pi. I'm not writing the cf and pi. Cf means complementary function and pi means particular integral. And the notations are d is equal to dou by dou x and d dash is equal to dou by dou y. D means d by dx, d dash means dou by dou y. These are the first order partial derivatives with respect to x and y respectively, d and d dash. So we have rules to find complementary functions. Rules for finding complementary functions. Rules for finding, I'm simply writing CM. Okay. First, I'm taking second order linear differential equation with constant coefficients. Let us consider second order linear partial differential equation with constant coefficients. Okay, for our convenience, we are consider second order linear differential equation with constant coefficients. The equation is in the form of dou square z by dou x square plus sum a1 into dou square z by dou x dou y plus a2 into dou square z by dou y square is equal to 0. As we know the notations, you have to remember d means dou by dou x and d dash means dou by dou y. And substitute here in this, we get d square z plus a1 dou by dou x means d, dou by dou y means d dash, z as this, plus a2 into dou square by y square means d dash square into z is equal to 0. So we can take z as common. So d square plus a1 d dash plus a2 d dash square d dash square into z is equal to 0. So we can consider this is the homogeneous equation. We can divide the entire equation with d dash square. While dividing d dash square, we get the equation is in the form of d square by d dash square plus a1 d by d dash, one d dash will be cancelled, plus a2 d dash square is cancelled into z equal to 0. Okay. So after dividing with d dash square, you can write the corresponding auxiliary equation. Just write d square by, you can write, I'm writing one more step here, d by d dash whole square plus a1 into d by, sorry, okay, jump అవుతుంది. Okay. Now here I'm writing d by d dash plus a2 into z, a2 into z is equal to 0. So అనిపిస్తుందండి ఇది a2 into z. Now we can write the corresponding auxiliary equation. AE means d by d dash equal to m, that is m square, and a1, this is 1 into m plus a2 is equal to 0. Okay, we are writing d by d dash as m, so m square plus a1m plus a2 equal to 0. ప్రతిసారి ఇలా d dash తోటి డివైడ్ చేయకుండా సింపుల్ గా ఈక్వేషన్ లోనే ఇక్కడే d square plus a1 dt dash plus a2 d dash square లోనే take d is equal to m and d dash is equal to 1 తీసుకోండి. తీసుకుంటే ఈక్వేషన్ వచ్చేస్తుంది m square plus a1m plus a2 equal to 0. That is the corresponding auxiliary equation. Okay, మనం ప్రాబ్లం చేసేటప్పుడు డైరెక్ట్ d equal to m, d dash is equal to 1 substitute చేస్తే auxiliary equations. This is a quadratic equation in terms of this is quadratic equation in, one second, share stop చేసి మళ్ళీ షేర్ చేస్తానండి, no problem ఉంది. Okay. Yeah. Okay, now we are, if you take d equal to m and d dash equal to 1, we'll get the auxiliary equation, which is quadratic equation in m. It has two roots. The roots are maybe real roots or complex roots. If the roots are real, there is two conditions. The roots are distinct or repeated roots. If m1 comma m2 are distinct roots of an auxiliary equation, then we can write the complementary function CF as f1 of y plus m1x plus f2 of y plus m2x, when the roots m1 and m2 are distinct real numbers. It may be complex numbers also, we can write m1 m2 are complex numbers. You can write f1 of y plus m1x plus f2 of y plus m2x, where f1 and f2 are arbitrary constants, where f1 and f2 are arbitrary constants. అదే మనం ఆర్డినరీ డిఫరెన్షియల్ ఈక్వేషన్ లో ఎలా రాసాం, రెండు రిపీటెడ్ రూట్స్ ఉన్నప్పుడు కాంప్లిమెంటరీ ఫంక్షన్ CF ఈక్వల్ టు C1 e పవర్ m1x ప్లస్ C2 e పవర్ m2x అని రాస్తాం. ఓకే, ఇక్కడ డిఫరెంట్ గా రాస్తాం. ఇక్కడ C1 C2 ఆర్బిటరీ కాన్స్టెంట్స్ అవుతాయి ఆర్డినరీ డిఫరెన్షియల్ ఈక్వేషన్ లో. ఇక్కడ f1 f2 లు ఆర్బిటరీ ఫంక్షన్స్. if m1 is equal to m2, if m1 is equal to m2 means the roots are repeated roots. When the roots are repeated, then the complementary function CF is equal to f1 of y plus either m1 or m2, we can take both are same, means I am taking m1x plus x into f1 of y plus m1x when the roots are repeated twice, m1, m2 are repeated. So in this case, we can write like this. If this is for two roots, okay. If three roots are distinct, if m1 comma m2 comma m3 are distinct roots are zeros of an auxiliary equation, then the corresponding complementary function is f1 of y plus m1x plus f2 of y plus m2x. Okay, ఇది కంప్లీట్ చేస్తాను సార్ నేను. Plus f3 of y plus m3 of x. If three roots are if four roots are distinct, then we can add f3 y plus m4 of x. Okay, ఇక్కడ నేను ఇది ఏంటి అంటే ఇది క్వాడ్రాటిక్ ఈక్వేషన్ వరకు ఇది అయిపోయిందండి, ఈ స్టోరీ అయిపోయింది. ఇక్కడ వరకు టూ రూట్స్ తోటి అయిపోయింది, ఇక్కడ వరకు అయిపోయిందండి. ఒకవేళ త్రీ రూట్స్ ఉన్నప్పుడు అంటే క్యూబిక్ ఈక్వేషన్ తీసుకున్నప్పుడు, క్యూబిక్ ఈక్వేషన్ కు త్రీ డిస్టింక్ట్ రూట్స్ వచ్చినప్పుడు కాంప్లిమెంటరీ ఫంక్షన్ ఇలా రాస్తాం. ఫోర్ డిస్టింక్ట్ రూట్స్ వచ్చాయనుకోండి, యాడ్ చేసుకోవాలి. ఫోర్త్ ఈక్వేషన్ కు ఫోర్ రూట్స్ ఉన్నప్పుడు f4 y plus m4 of x అని we can add. Like that we can adding. If m1 comma m2 comma m3 are repeated roots, that is m1 is equal to m2 is equal to m3, then the complementary function CF is equal to y plus m1 of x plus x into f1 of y plus m1x plus x square into f1 y plus m1x. Three repeated roots. అలాగే four repeated roots ఉంటే, అనుకోండి, x cube f1 of y plus m1 of x, ఇలా మనం కంటిన్యూ చేసుకుంటూ వెళ్ళాలి. ఓకే, దీస్ ఆర్ ది రూల్స్ టు ఫైండ్ ద కాంప్లిమెంటరీ ఫంక్షన్స్. ఓకే, టుడే విత్ దిస్ ఐ కంక్లూడ్. టుమారో వి కంటిన్యూ విత్ దిస్ లీనియర్ డిఫరెన్షియల్